in this particular session, I will take you through some of the software engineering basic building blocks. It's not simply developing a web app or mobile app, it's more than that. And what are the different careers in software engineering? Usually people think there's only people like to do coding or people want to do the testing, but there are a lot of other associated skills and roles are around software engineering. And then software engineering in terms of at UTS, what we special about. Camilla mentioned about some of the cutting edge technologies we teach to our software engineering graduates, which are highly in demand. And then some of the areas of software engineering and engineering in general, and what are the other courses are which can be combined. And finally, we wrap up with some of the Q&A as we go through. So thinking about what is software engineering, software engineering is not about only writing a small piece of code. Software engineering is a kind of main software engineering, very much like any other engineering. It's involved a systematic design and development of the software products. It's also required that software which we develop, they meet different standards, ISO standards or security standards or privacy standards, which you've probably heard of that. Also, software requires a lot of resources to be developed and different people and different infrastructure is involved in that. So we want to make sure software we develop, it is finished on time and it's done within a given budget. As small software can be written for $50,000 to maybe a multi-million dollars of budget. So you can say that scale of the software engineering could be very different from small to large to very complex. And having said that, our society in general depends on the software engineering, whatever we do. Even simply buying a coffee depends on technology as well, as you can see that when you have to go to the coffee place and then you have to make an order, and then at that time the coffee maker or the person who's serving coffee gets an order, and all that goes through a software system behind the scene, and a lot of things happen behind the scene as well. And even the current webinar, what we're doing is done via software. So software engineering is everywhere, what you can think of. And when we do the software engineering, it's important. It meets that desired specification, and it is fit for purpose, and it's be able to deal with the errors. Or if there's an error, it should be able to notify you as well, so it fails safely. So when you design software, it's not about only writing program, but also being able to write a program. If there's an error, it should be able to deal with it. In terms of software engineering, one question probably maybe could come to your mind and my mind when I started looking into software engineering many years ago when I was a student. Why I wanted to study software engineering. Very obvious reason was for me the software engineering was coming as a mainstream engineering and still growing. You can see that it has different applications. You can say an application is medical science, application in business, application engineering, and even the other ways of what we do, mining, environment, everywhere is a software. So there's a lot of demand of software engineering professionals, and that was the kind of a reason why people want to do software engineering as well. And it's not only demand, but sometimes it's fun as well, in a sense, because software engineering challenges you and your ability to think creatively and being able to bring innovative thinking and express that thinking in terms of the software programs. So that's really software engineering keeps motivated me and some of the people who are professional working in the industry. Some of the examples of the software engineering is applications. As a software developer, or software engineer, or as professional, you might be developing a web application, might be mobile application, might be looking at the cloud, online Amazon, if you have seen that, buying books or selling them, buying different other merchandises. And then software can be embedded into some other kind of hardware, where it could be embedded software engineering. It could be reading data from IoT devices deployed in the environment, in the building, which we hear a lot about smart cities, smart building. So all those applications, they are IoT or software applications. IoT, what I mean by that, Internet of Things. And then there are system software. Whenever we use a software on our computer, the first thing we needed a system software, like your operating system, which manages your hardware before you use any other application. Then there are the multimedia software, visualization software, then the microcontrollers controlling your engineering equipment, maybe robots controlling and doing work for you in the factories and manufacturing things for you. And behind the scene, there are data management systems as well. We'll hear a lot about the AI and machine learning and analytics and smart system. All depends on the being able to manage data well, and that's where the data management system comes into play. You might be working with different databases around there. And then there's a monitoring and control system. You can see that aircrafts monitoring and controlling them, or maybe controlling cameras in the city. All these and monitoring the traffic. All this is done via software. So software is everything, and probably our world would be eaten by the software. And that's actually already happening. Software is doing a lot of stuff which we used to do as a human, and now humans are actually teaming up with the software to do better and the best thing for us. At that point, I'm going to take a little poll around here. Daniel, I can kick off the poll around here. But just to understand what you know about the difference between the computer science and software engineering, and that's an obvious question sometimes pops up. So what do you think about the computer science and software engineering? I think I can see a lot of things are happening around there. I think that I would say that about 25% people, they understand that, and 36% of people are nearly saying they are unsure about it, and some of the people actually don't know about that. So I will take you through very quickly on that. What's the difference between computer science and software engineering in a second. So in terms of the computer science, science is always, when it comes a word into our mind, we think about some kind of abstract thinking or theory. So from a computing point of view, computer science could be a theory, but not as such kind of a theory, which is just a theory. But in terms of software engineering point of view, we can call computer science as a theory. It can tell us how to do things. It can even provide us tools which we can use to develop or engineer software. So computer science is all about the tools and technologies and theory they provide us, which we can use to actually practice software engineering, and we can actually do the things and develop the software. Very typical example of the computer science could be algorithms. You can develop different algorithms as a logical thinking, or there could be a programming language which can be developed like Java or Python or JavaScript. These can't be programming languages, and how they work, they could be developed by the computer scientists. But software engineers, they use those programming languages and tools developed by the computer scientists and actually develop software for businesses, for medical science, and for other purposes. So software engineering is actually putting computer science into practice. So this is a kind of a high level difference between them, but there are also common points as well between them. Both requires logical thinking and systematic thinking, and being able to reason, and being able to develop algorithms, and being able to use technology. So both sides, technology is overlapping, and other things overlapping as well. When you're looking at the theory and practice side, computer science is not only all about theory, but also something which can be put in action by the software engineering. When we talk about software engineering, it's important to understand what is the challenge is around there as well. When we develop a software, whether you're a small company or a large company, medium size, whatever the companies are, they're using software. One thing is important is that software is about innovation, bringing new things, or maybe doing the old things in a new way. So maybe using the manual things, automating using a software is also an innovation. But innovation always is risky. So there's a risk element attached with that. There are a lot of unknowns sometimes, and that's the interesting part in software engineering. When you deal with the uncertain things, when you develop a software, then software system must be robust and reliable. They should be fit for purpose. Reliability or robustness is that if we are using this today, this Zoom as a software. So it must be reliable to be able to communicate the video and voice when we need it. So that's where the software is thoroughly tested to make sure it's robust and reliable. And also, it must know how to deal with the unlikely and unusual combination of events. If the different things are happening at the same time, it should be able to deal with it. The very typical example is that while I was presenting to you here now, through the Zoom software, we able to launch the poll. So that's another event. And then we can correlate the poll data with what we're presenting. So that's that. And then we're able to switch on and off voice and video and other things, and being able to include people in that share screen. So you can see that a software can deal with multiple events at a given time. And as a software developer, you think about those different kind of events from possible use cases. So that's about the very simple Zoom we use. Sometimes we don't think about it. How complex is that in behind the scene? Further complex, you can look at that. The Space Science, NASA, the software was developed for lunar landing back in the days. Then also when you develop a software, you make sure it is accessible to everyone. With the people with special needs should be able to access and use software as well. So it's quite a complex thing, which we need to thoroughly understand the requirements before we develop it and then test it thoroughly and before it's actually being used by the end users. Since software engineering is a very interesting and a challenging discipline as well, but it offers a lot of roles. It's not only about the writing code. If the software engineer, typically they can write code and test the software. They are development managers who manage the software engineering teams. Software can be deployed into the real environment, which we call operations. So development and operations could be another area. DevOps manager, system engineers, people who actually behind the scene, they configure the hardware and the software for the end user or for the developer. Then the software consultant, you can work, you can advise, you can write requirements, specifications, you can design the user interface of the software, which is pretty much a UX, user experience or customer experience designer. Then, like any other engineering, construction or civil or other engineering, there's an architect involved in that who can design the software components which can work together to address the end user's need. Then the software quality assurance analyst, people who can test the software, test it for a fitness point of view, reliability point of view, robustness point of view, all the things we just discussed. Then also software is like a product, like any other product we have in our hand. It might be you don't see it, but behind the scene, whatever the code you see, write that's actually a product. So in order to manage the ongoing maintenance and the operations of the product, we need a product manager. Then we can need a technology analyst who make sure that technically they analyze the software requirements before actually you build it. So there are a lot of career opportunities. You can see that here. It's not only a one kind of a role fits into in the software engineering. The more new roles are emerging as well, like the mixing with the data and the software engineering together, a role of a data engineering coming up as well as a part of that. Infrastructure engineering role is coming up. Cloud software engineering role is coming up. So as the software engineering is evolving, then many roles are coming up as well. And the more opportunity would be there for the graduates. In terms of the engineering courses at UTS, we have a Bachelor of Engineering and honors as it's coming as together, but majoring in different areas. Here we are discussing tonight the software engineering as a major, as a part of a Bachelor of Engineering honors. And engineering degrees can be combined with other programs as well. You can see that it's flexible, the way we have software engineering structure, which I can take you through very shortly. But there are other kind of engineering is available as well, mechanical, biomedical, which are very typical traditional electrical engineering and all these things. A typical course structure is spread across 5 years, and you can see that there are red items highlighted. These are the core subject from an engineering point of view, which you covered in the first, second, bit of third and fourth and fifth year as well. And then there are blue highlighted colored area, which is a software engineering related, major related core subjects. Then also you have a software engineering related electives, which are in a black color highlighted around there. And then further little lighter color around there, you can have that. You have further free electives as well. So it's a combination of a core engineering skills and education. Then we are specifically going deep dive into the software engineering related core on the top of the engineering foundation. And then you have electives as well, to building in the flexibility of the software engineering electives. And then you have some free electives coming as well, which can diversify your program as well. Further, across through the program, whatever you learn, you get to practice at the university as well. So we have more practice-oriented studios spread across starting from second year all the way to the third and fourth and the fifth year. These studios will give you the opportunity to practice your skills, which you learn through those subjects which you studied both in core of engineering and electives, both software and the free electives. And this is the opportunity where you work on projects and being able to apply your skill to different software projects. In addition to that, further deepening your knowledge into software engineering in this 5-year program, intensive program, we have diploma professional practice, which are 2 internships you do. One is probably maybe around the end of second year, and the final internship comes around another 6 months towards in the 4th year. This is really putting your knowledge, whatever you learn from this degree through different subjects and studio into real world projects and in the industry. And this is a kind of a bridge from moving from a university to going into a professional world. And this diploma or professional practice bridge that gap and allows you the opportunity, your window to work with the industry and being able to develop your skills and apply your skill with a view to become a professional software engineer in the near future. In terms of diploma and professional engineering practice, as I mentioned, you will complete 2 6-month internships, and one is the second year, and then one would be in the 4th year. And that's really about connecting your studies to the real world and getting hands-on with the engineering skills you develop in applying that industry. And also, it's really important you have technical skills as a part of your software engineering program, but also it's really important you be able to network with the people and organizations so you can be able to communicate what you know. So having a good technical skills is one thing, but it's also important how good you are communicating in them to your future employers. And sometimes the top employers, they actually look at both kind of skills, being able to be technically proficient, but also being able to communicate what you can do it for them and for their end users and customers. At that point, I think that's pretty much from my side for now. I'll be there for answering any question later on. I will pass it on the control to Jennifer now to take you through the rest of the presentation. Jennifer, over to you. Thank you.
Hi, everyone. Thanks for the handover, Asif. So I'm Jennifer. I'm currently in my 4th year studying a Bachelor of Software Engineering with the Diploma in Professional Practice. Like Camilla, I chose UTS for the practicality of the degree, especially with the integration of the internships, which I found has been quite valuable and quite interesting for me. And I've been fortunate enough over the course of my degree to complete different internships spanning from startups coming from the UTS startups community to a multinational consulting business. I think for me, UTS is quite an exciting place to be and some place that I really wanted to go as a student when looking where I wanted to study engineering, specifically because of the high practicality component, but also the well balance of learning the theory, but also having ample opportunities to apply them, whether that be through practical units such as studios, labs, or workshops, or even your internships. And I think internships are a great opportunity for you to not only apply what you've learned and sort of see what it is like out in the industry, but it gives you an opportunity to try out different roles and different sort of career paths and niches within your degree before you graduate. So it's a great way to sort of test the waters and figure out where you really want to go after university. And outside of the internships, I think UTS also offers a really wide range and great opportunities where students are supported and encouraged to explore different things that are outside of their degree and try something new and challenge themselves. And I think great examples of these opportunities take place in programs and I guess units such as UTS Startups, which is a community in UTS where students are encouraged to build up businesses of their own and are given the resources and the support from different leaders and experts to actually help them actualize and realize their goals and dreams to build up their business of their own. And actually, one of UTS Startups is actually quite successful and was listed in one of Forbes 2021 lists. So that's quite exciting for us as well. But yeah, outside of UTS Startups, UTS has previously also run accelerator programs, which I've participated in personally and got the opportunity to sort of learn how to build something from scratch in a very short period of time, but work with a range of different individuals from different students in different years across different faculties, but also different industry professionals and academics in UTS too, which is really cool. And I guess the final point that I think is really cool and exciting about UTS is we have a range of different student-led project teams. And what a student-led project team is exactly what it sounds like. It's a team of students from different faculties in the university spanning different study levels, so from undergrad to postgrad, as well as other research students, all just working together to develop a project that can later be practically applied or actually compete against other universities. And I think some examples of these are our student teams such as the Rover team in UTS, which actually recently competed in Adelaide in the Australian Rover Challenge, which simulates a lunar rover, which is pretty exciting, as well as our Motorsports Autonomous team and Electric team, which are both building vehicles for competition against other universities. And I've been fortunate enough to try out a lot of these different opportunities and think it's one of the great I guess, opportunities and chances that are available at UTS and quite unique to UTS because you're getting the opportunity to try out different things and also learn and apply things within your degree in sort of niches and new fields that are emerging and expanding in the STEM world.
Thanks, Jen, for sharing your story. So we'll move on to the rest of our presentation. So a lot of you guys are currently in year 12, so you're probably wondering what's the ATAR that I need to get into this course to secure my spot at UTS. So if you go on our website, we actually give out the lowest possible selection rank of entry for our courses, which is a combination of your ATAR plus possible adjustment points that you will receive through the numerous UAC rounds that you will go through towards the end of this year. So another word or another term for adjustment points is what you guys would know as bonus points if you guys are talking to your high school teachers or even to your high school guidance counselor, learning more about your opportunities here at UTS. Just please note that these adjustment points are capped at 13 points here at UTS. And these adjustment points can be given for a number of different factors, including completing the UTS and Engineering and IT questionnaire, good results in relevant HSC subjects, which is what we call as Year 12 subject scheme. So this is an automatic scheme that you guys don't need to directly apply for. Once you guys get your HSC results in December, all of these subjects results will be automatically calculated for your ATAR results for the week after. You can get adjustment points for your gender, special circumstances, and even more. So if you guys would like to learn more about adjustment points for these UAC rounds, please feel free to take a photo of the QR code on the screen or even scan it, and it will take you directly to our website for more information. So on the next slide will be the UAC dates. Basically, if you guys are in year 10 and 11, this may not be as of interest for you guys, but for year 12 students, this may be potentially of interest. So key dates before moving on to key UAC dates would be that we currently have our scholarship applications open. If you would like to apply for scholarships, I highly recommend you guys applying for our scholarships. There will be more opening up until June, with these applications closing at around September of this year. Further to note, we also have our open day already situated. We will be having it on the 27th of August, and everyone is welcome. We will be having it as a hybrid open day. So we will be having webinars online, but we will also be on campus. So if you are a parent, student, teacher, or just a general visitor, you're more than welcome to visit us on campus then. It will be on the Saturday of August. So please feel free to come in then. In regards to your HSC exams, according to UAC, will be held during October to November of this year, with scholarship offers released during that period of time and shortly afterwards. In terms of your UAC offer rounds, there will be multiple offer rounds that will be made through UAC. With each of these offer rounds, you can actually change your preferences for each round and receive offers in each round that you are applicable for. So please feel free to change your preferences as you see fit, and even switch it up if you do see that you feel like you would like to learn more about, for example, engineering or even IT, with software and IT being so similar. But please note that UAC change of preference dates. So there will be a last date before each offer round closes. So you'll need to make sure that you keep in track of those dates, just to make sure that you guys have the right preferences put in place for that particular offer round. We will be having further webinars in details for that, but that will be coming up later. We will be having your ATARs and your HSC results will be released in December, with our UTS orientation in February and official class start in March next year. So we did start this program last year, and we're bringing it back again for 2022. So we will be having the UTS early entry program, and it is a great way to receive an offer to study at UTS before you even sit your final exams, whether it is your HSC or your IB. So if you are a CARA domestic or international onshore year 12 student, you are eligible for this program. And applying for this program is very easy. It is a direct application through our website, and it will take you to a UTS online application portal, which is very different from UAC. So you will not be using UAC for this UTS early entry program application. It is free to apply. There is no fees required for you guys to apply for this program, with applications due to open either between June, July, and will close in September. Currently, their dates are yet to be confirmed, so please see the website for updates and further information in regards to this early entry, UTS early entry program dates. If you are successful in this UTS early entry program, you will be receiving provisional offers, which will be released in October before your HSC commences. And to complete this provisional offer, you must complete the HSC or equivalent, such as the IB. To find out more information on how your points can be maximized when applying for engineering and IT courses, or even more about the UTS early entry program, please feel free to scan the QR code up on the screen right now for further information. We do have a number of student support services that is available for UTS students, such as bridging courses offered in mathematics, physics, and chemistry. At UTS, we have no prerequisites, so there is no requirement for you guys to study any specific topics or subjects in high school in order to gain entry with us. I personally did a bridging course in mathematics and physics, not having done physics in high school, and I just wanted a little bit of support in mathematics, and that helped me throughout my first year. And it is definitely something that you guys can do before you officially start studying here at UTS as well. We also do have UPass, or what we call Peer Assisted Study Success, available for selected subjects. So UPass is free tutoring services, which is run by high achieving or high performing students from previous semesters, assisting you to gain the very best of that mark in your degree, in that subject. So that is free for some subjects, and we do have several more student support services which can be found on our website.